Okay, regarding this Einstein-Rosen paper, basically you could have something spitting out a photon in, say, the center of a room. You have a detector on the right, a detector on the left. The photon or whatever particle is spit out, it's in a wave state until it's observed by the detector on the right and the left. And the detector on the right and left are basically saying there's entanglement where the particles are connected. Now, Einstein's problem is time, right?
Yeah.
He's saying that, like, if you push a domino, the next domino takes time to fall, right? That's his big problem with it. But time, this just prove that time is not a thing? This gets back to that whole thing. The past, present, and future are all the same thing. Yeah.
But there really isn't time.
Yeah, I guess my point is that entanglement is another way to prove time doesn't exist, which I never thought about until now. But entanglement is actually, I always say if you go the speed of light, it stops, and if everything in the universe stops moving, time ceases to exist in those two conditions. But even if you're not in those two conditions, entanglement says that time ceases to exist now. Like right now.
Right, because
Right now, there is no past, present, and future is what entanglement is basically saying, right? Because I push a domino, in this case, what, a photon, whatever. The experiment is a photon spits out instantaneously the same measurement at two locations. That means time is not a factor.
yeah, isn't that true? Haven't we heard that somewhere before? Like the entanglement happens faster than the speed of light.
Is that right?
I feel like that we heard that somewhere.
Okay. There was something else I wanted to say about this. Hang on. Let me rewind this real quick.
Space, together with time, was the key ingredient in his theory of special relativity. With its famous equation, E equals mc squared.
I'm playing this thing to remember.
Einstein, of course, was the master of space-time. He thought that if something happened here, that shouldn't immediately and instantaneously change something that is going on over there, the principle of locality, as we currently call it.
No,
For Einstein,
that's not what I wanted. Darn.
And yet, according to quantum mechanics, a choice to measure something here is somehow instantaneously affecting what can be said about this other particle. You can't go from Princeton to Andromeda instantly, and yet now...
Oh, that's what I wanted to talk about. This implies wormholes are a thing to me. That's the other thing I wanted to say. Entanglement is basically a little mini wormhole. You could view these particles. Okay, it's spit out of the thing in the middle of the room, detected on the right, detected on the left, instantaneously. I don't know. I'm a little fuzzy on that. Maybe I'm wrong. Maybe someone could help me with that. But my point is there might be a structure. Forget wormholes, I guess, because I can't be sure I know what I'm talking about. But there might be a structure like a wormhole
Yeah.
that these particles are going through and they're being detected, right and left.
I almost visualize it less like a wormhole and more like an X and Y chart where like there's waves, like maybe two sets of waves, and then like when one point is measured on one wave, it shows a parallel dot on the other wave. Like the wave stops and now they're like, it goes from being a wave to like a line connecting two dots. That's sort of how I'm picturing, almost like a field that creates.
Well, that's exactly what I'm talking about. A line connecting two dots is just the same as a wormhole connecting two dots, right?
Yeah.
So we're saying the same thing, I think. Yeah.
Yeah. I guess it's just a matter of how they're
big-
connected.
I guess the big point is it's an invisible structure, probably, that's connecting me. A particle here in the U.S. being connected to one in Africa is probably just connected through some type of thing that is similar to a wormhole, if not a wormhole.
Yeah.
It's some kind of structure like that. Maybe a Calabi-Yau manifold or, some kind of dimensional thing. But there's something we're not seeing and we can't detect that's probably there. And that's how these are entangled, right?
Yeah. And also you have to think about them as sets of probabilities. So it's suggesting that two sets of probabilities are tied in some way.
Yes, that's a good point. Or it's the same set of probabilities and it's looking like it's two and it's actually just one.
Right.
Which one makes more sense? The one you're talking about suggests like an alternate you somewhere else exists,
Yeah.
It'd be like the doppelganger particle of you or something.
Yeah. And don't
Yeah.
these particles also tend to have opposite charges? Like one is a one.
Yeah,
And one
I think
is-
that's how we know they're connected is every time you turn the one
Yeah.
positive, the other goes negative.
Right.
Yeah, like over and over. So
You know what it's like? It's like if a guy who's playing on the Dodgers hits a home run and the
Yeah.
guy on the Yankees has to strike out.
holy shit. Every time.
Yeah.
That's amazing. Wow, it is like that. So what does that mean?
Don't ask me.
It means they're connected,
Yeah.
but like why and what does that mean,
Yeah.
It's almost like yin and yang in a way. Like
Yeah.
if your life is bad here and you're striking out, your life is good as your doppelganger on the Dodgers hitting a home run.
Right.
So in a way, it's kind of hopeful.
Yeah.
Like if your life is bad, there's a life maybe of a good you somewhere.
Yeah. You're on the negative charge. Somebody
I
else.
want to be on the positive charge. I'm clearly on the negative.